Welcome to lesson number 2 of Unit 7. Now we're working on multivariable systems. So yesterday we worked on 2 variables in 2 equations. Now we're going to be working with 3 or more variables with 3 or more equations. We're going to be sticking with 3 and 3 for this lesson. We'll wait for the 4s and 4s and higher for the next lessons. Right? You see right away a warning. It says that these problems can be difficult. No one method works better than any other that I know of. You might do a bunch of work, find an error, and then have to start all over again. Hey, guess what? That happens. Happens to the best of us. Just keep trying. That's really my warning for this, right? You're going to probably mess up because it happens. They're not the easiest things in the world to do. Here's my general way of doing this. This is how you're going to see me doing them. Remember how I told you no one method works better than another? This is just how I find it easiest for me to do. Okay, so here's what I'm going to be doing. I'm going to use elimination method on 2 equation combos, right? So we're going to have 3 equations, going to do it on 2 combos, eliminating the same variable both times. Then I'm going to solve the resulting new systems any way that I can. At this point, I can either use substitution or elimination method again. It doesn't really matter. But I should be able to solve for both variables at this point the way that we've seen in the last lesson. Right? So this right here should be pretty familiar to us. And then finally, I'm going to substitute both values into any original equation to find that final variable. So this is my method. It seems to work for me, but I have had other people say that they like doing it a different way better. I don't know. Do it however it's easiest for you. Okay, but just keep in mind, you're going to probably want to do this in pencil. I'm doing this in pen just because it shows up a little bit easier. And I have a pretty good idea of what I want to do for each of these. Okay, so here's what I'm going to do. I had suggested that I'm going to do elimination method on any 2 combos. So I'm going to do my first on these first 2. And what I'm noticing is I've got a negative x and a positive 5x, that if I just multiply this bottom thing times 5, then I'll be in pretty good shape to get rid of my x. So I'm going to copy down the first piece. I'm going to multiply this thing times 5. Right? Times 5 gives me negative 5x. Times 5 gives me minus 25y. Times 5 is 30z. 24 times 5, that's negative 120. Okay, if I now do my addition, my 5's eliminate. Negative 29y plus 32z equals negative 99. So that's one combination. I did my top and my middle. I'm going to do my second combination with these 2. And I'm going to eliminate x again. And I'm going to basically do the same thing. If I multiply this entire bottom piece by 5, I should be able to get rid of those x's. All right, so let's see it. I'm going to copy down this top part again. 5x, 4y, 2z, 21. This bottom piece I'm multiplying by 5. So negative 5x minus 20y plus 25z. 21 times 5, that's 105. When I add, my x's eliminate. Minus 24z plus, y rather, plus 27z. Negative 105 plus 21 is negative 84. So, just quick recap. I did one combination, got rid of my x's. Did a second combination, still got rid of my x's. Now I have y's and z's. These are something that I can handle now, right? Negative 29y plus 32z equals negative 99. Negative 24y plus 27z equals negative 84. Now it doesn't matter which ones I want to get rid of. I can get rid of either y or z. I'm going to get rid of y. If I multiply the top by 24, the bottom I would have to do 29, but if I want this to stay negative and this one to change to positive, I'm going to have to do negative 29. If you have a calculator, this is a little bit easier to do because I have to distribute. 24 times 29, that's negative 696y. 24 times 32, positive 768. And then 24 times negative 99, negative 2376. So that distributed to the top. Now I have to do to the bottom. Positive 696y when we multiply here. When we distribute, minus 783z. And when we distribute here, positive 2436. Again, use a calculator if you need to get those values. Okay, this is what we come up with. Now once we add, we're going to eliminate y. Right? Y is gone. This gives us negative 15z. And this gives us 60. Divide by negative 15. We get z equals negative 4. So we've got one of them. Once you get one, everything kind of goes downhill from there, right? It's pretty simple at this point. I'm going to take this value and I'm going to plug it into either one of these two equations. I don't care which one of these two. I'm going to choose this bottom one. Negative 24y plus 27 times negative 4 equals negative 84. So that's what I need to start solving. Let's see, 27 times negative 4 is negative 108. Let's add 108 to both sides. So negative 24y equals, that's going to give us positive 24. Divide by negative 24 on both sides gives us negative 1. So now, once we found one variable, we got that second one pretty quick. Now we just got to plug both of these into any of the original equations. Again, it does not matter which one you choose. I'm going to plug it into the top because I don't have that negative. I've just got a 5. I'm fine with dealing with that. So 5x minus 4 times y, which is negative 1, plus 2 times z, which is negative 4, equals 21. Let's see, that's plus 4 minus 8. Five x minus 4 equals 21, so let's add 4. 5x equals 25. And we come up with x equaling 5. Now, you would want to check, obviously. You're going to plug in your x, your y, and your z and see if it equals. I'm not going to do that here to save time. You will want to do that on a homework quiz or a test that's part of your actual work, so please make sure you do it. But again, just to save some time, that's what our final answer is. We write it in coordinate form, x, y, and z. So I've got one for you to try. My method seemed to have worked. If you want to try my method, try it. If you have a different method that you think works better, go for it. I'm not going to stop you. What I would suggest is you pause this video and resume it when you're ready to check. But really, try it before you just go, watch the solutions. You really want to practice this on your own. All right. What I'm noticing is I've got a 4, a 4, and a 4. One of them positive, the other two negatives. So if I'm going to eliminate a variable right off the bat, I'm going to get rid of my y's. Here's the combinations I'm going to do. I don't have to multiply anything, right? They've already got the same coefficient. So I'm going to do 4x plus 4y plus z equals 24, and 2x minus 4y plus z equals 0. When I combine those, 6x, y's go away, plus 2z equals 24. That was pretty simple start. And then I'm going to do these two. Why? Because I have positive 4 and negative 4. That's going to eliminate the same variable as last time. So 4x plus 4y plus z equals 24. I'm using the bottom one now. 5x minus 4y minus 5z equals 12. When we combine 9x, our y's cancel. Minus 4z equals 36. So now I've successfully eliminated one of my variables, right, from both of these equations. Got rid of y. So now when I look at 6x plus 2y equaling 24 and 9x minus 4, oops, I'm sorry, this should be z, not y's, z equaling 36. Now it's a little bit easier for me to work with, right? I like elimination method. I know that I need this to become a positive 4 because I've already got negative 4. So I just have to multiply by 2 here. So 12x when I distribute plus 4z equals 48. Remember to distribute all the way through. Down here we haven't touched it yet, so 9x minus 4z equals 36. Our elimination method works beautifully here. 21x, get rid of the z's, 84. And if we divide by 21, we find x to be 4. So yeah, it was a lot of work to get to just x, but at this point, it's kind of quick, right? I'm going to plug in to this top expression. 6 times 4 plus 2z equals 24. 24 plus 2z equals 24. Get rid of that 24 from both sides, leaving you with 2z equaling 0. Divide by 2. We get 0 for z. Two of them. That was a lot quicker that time, right? Now we can plug into any one of these. It really, truly does not matter. I'm going to plug it into this middle one because I have a plain old z and a 0. So why not? You got 2 times 4 for x minus 4y because we don't know y yet, plus z, which is 0, equals 0. That's 8. I'm not going to rewrite that 0 over here. It's really kind of useless. Let's subtract 8 from both sides. So negative 4y equals negative 8. And that leaves us with 2. Then, as mentioned, you need to check. If you plug in 4, 2, and 0 to each of these, you will come out with 24, 0, and 12. So your final solution set, 4, 2, and 0. I hope that wasn't too frustrating. I know I went kind of quick, but just so you know what we're doing, or at least my method of doing these, elimination method on 2 combos, right? Here's one combo, here's the second, eliminating the same variable, then use those 2 new equations and work like usual. It seems to work for me. I don't know. If somebody out there in the internet world has a better idea, you can share it. I'm open to suggestions here. Well, until next time, see ya.